Hello everyone! In this video we will get acquainted with natural numbers, learn how to read them correctly and most importantly, learn how to solve problems and prepare for the next videos of the course. In order to talk about natural numbers, we first write down their definition. Natural numbers are numbers that occur naturally when counting and determining the order of placing items. These are numbers 1, 2, 3, 4, 5, 6, 7 and so on. It's important to know that 0 is not considered as a natural number. Let's draw a tree and using natural numbers calculate the total number of apples. And we will see that there are only 7 of them. Natural numbers are also used to indicate the number of items. For example, in our drawing, after the tree was shaking, 3 apples fell on the left and 4 on the right. Any natural number can be written using 10 digits from 0 to 9. This notation is called decimal. Depending on the number of digits that make up the number, it can be single digit or multi-digit. For example, 8 is a single digit natural number. 26 is 2-digit, since it was formed by using 2 digits, namely the digit 2 and the digit 6. 777 is a 3-digit number, and 1,234,841 is a 7-digit number. It's very important to note that there are only 10 digits with which numbers are written. It means that 26, 777 or 1,234,841 would be wrong to call digits, but 8 can be called both, a number and a digit. To make it easier to understand, let's give an analogy. Just as words are written using letters, numbers are written using digits. So a digit is like a letter and a number is like a word. All natural numbers written in ascending order form a series of natural numbers or natural series. The first number in the natural series is number 1, the second is number 2, the third is number 3, etc. In a natural series, each number is followed by one more number, which is greater than the previous one by 1. Therefore, there is no last number in the natural row. The number 1 has no previous one, so among natural numbers there is the smallest number, the number 1, but there is no largest. Let's show the natural number and now we'll understand how to read them correctly. We see that each natural number can be divided into classes, each of which includes 3 digits. The smallest of the classes is the class of units, followed by thousands, then millions, and then billions. It's important to note, since there is no largest natural number, the largest class also does not exist, and the names for biggest classes can always be googled. Let's write out the number 231 billions, 653 millions, 229 thousands, and 478. And try to figure out why it's read this way. We see that 231 belongs to the class of billions, and if, in even more details, 2 means 200 billions, 3 means 3/10 of billions, and 1 means 1 billion. But in order not to say 200 billions, 3/10 of billions and 1 more billion, it's much easier to say at first the number and then at billions. In our case it's 231 billions. Then there will be millions and therefore let's say 653 millions. Then 229 thousands. And not to say 400, 7 tenths and 8 units, let's say 478. I will repeat how to read this huge number. 231 billions, 653 millions, 229 thousands, 478. And move on to the problems that I highly recommend trying to solve on your own and only then see the answers. Write down the number 27 4 times in a row. What number is formed? How many millions, thousands, units does it have? We will do as we said in the first sentence, divide this 8-digit number into classes, and we will see that there are 27,272,727 units. So we first answered the second question and saying that it's 27,272,727, we will answer the first question and move on to the next task. Write down the smallest 7-digit number and the largest 6-digit number. How many units is the first of them larger than the second? In order to write the smallest number, you must use the smallest digits, but since the first digit cannot be 0, we write 1 and after it 6 zeros, getting the smallest 7-digit number, namely 1 million. To form the largest 6-digit number, use the largest digit 6 times and get 999,999. To answer the question, subtract the second number from the first and get the answer 1. In the next task, you need to write down a 3-digit number in which the digit of hundreds is 3 times more than the digit of tens and 4 less than the digit of ones. There are several ways to solve the problem, but most importantly, they all lead us to the same answer. Let us denote hundreds by the number a. Since the number of tens is 3 times less by the condition, you can write what it is, a divided by 3, and the number of units is 4 more than the number of hundreds. A cannot be 0, since 0 cannot be the first digit of a 3-digit number. Also, a cannot be 1 and 2, since it must be divisible by 3 in order to get the 10th digit. Substituting 3 instead of a, we get that the required number is 317. I recommend to solve this problem by denoting the number of tens with the letter A. In the next problem, Julia wrote out several consecutive natural numbers in ascending order. The number 27 is the 7th, counting from both one side and the other. How many numbers did Julia write out? Which one is the smallest and which one is the largest? In order to say how many digits Julia wrote out, it's enough to notice there are 6 numbers after the number 27 and 6 numbers before the number 27. That is 6 plus 6 plus the number 27 itself, which is in the middle, and we will get the answer 13. To better see what it means, draw a number line and count to 1, moving both to the left and to the right. Now, having written the natural numbers that correspond to divisions on the number line, we will see that the largest number is the number 33, and the smallest, moving to the left, will be the number 21. In the last and the most difficult task, 63 digits had to be written to number the pages of the notebook. How many pages are in the notebook? It's very important to remember that digits and numbers are not the same thing. Therefore, from the first to 9th page, their numbers will be single-digit numbers. Further, everything is 2-digit. In order to calculate how many 2-digit page numbers the notebook has, subtract 9 from 63 to know how many digits are left and divide the result by 2, since the numbers will be half as many. We get that there will be 27 2-digit page numbers and 9 more which were written in single-digit numbers, and we get that there are 36 pages in the notebook.